Good morning and good evening, everyone. Uh, Today, we will be discussing a little more deeper on the Oracle database architecture. So, yesterday we have discussed only the terminologies and basic architecture, but today we're going to discuss in depth of each and every component in the Oracle database server. So, let's dive into that. So before we dive in there, so we just recap what we have discussed yesterday on the basic architecture. What are the terminologies we have discussed? Okay, so we have talked about the Oracle database core components and some terminologies. Okay, so let's see. We we have had a discussion around the uh, how a client connects to a database. Okay, and a listener. So what is a listener? Listener is a process that runs in the database server, which listens and decides the client connection, whether it is a legitimate to connect to the database. So basically, it will allow the uh, client connection to pass through and connect to the server process. Okay, so listener will have an information of IP address, port number, host name, um, databases ID, all this information. Okay, and then server process will handles the request coming from the client, basically user process, and then it will handle that user process request with the instance and database and fetch the information from the database and give it back to the client. Okay, so that is the server process job. And instance, so we talked about the instance. Instance is a combination of SGA memory, basically memory again comprise
Noisy.
memory is comprised of both SGA and PGA. And
Aynı gün zaten. Min Pride. Klein Million.
can you keep yourself mute? So SGA is comprised of two components. One is sorry, not SGA. Memory is comprised of two components. One is SGA, another one is PGA, and background processes. So background processes and memory together we call it as instance. Okay, and when you call database is comprises of data files, CRD data files, redo log files, control files. Okay, so those are the terminologies and we talked about. Let's see the next slide. So overall architecture looks like this. Okay, so system global area or shared global area, you can call the memory component, one of the memory component. Okay, so in within the system global area we have a shared pool, we have a, a large pool, database buffer cache, redo buffer cache, fixed SCA, Java pool, streams pool. Okay, so these are all SGA components. Okay, shared pool, large pool, database buffer cache, Java pool, streams pool. Okay, then we also have a PGA. Okay, PGA also will have a different components: SQL work area, session memory, private SQL area. So basically, PGA interacts more with the server process. So server process requires some memory, so that memory will be allocated by the PGA. Okay, to do the process of whatever the user request. Okay, so these are all the two memory components, and each memory component have a different components again. So after this, we have a different background processes: DB writer, checkpoint, log writer, arc writer, REV, WR, PMON, SMON, RICO, MON, all other different background processes we have. Out of all this, we will have a important background processes, mandatory background processes we will learn. Okay, so and then uh, we have a database which consists of redo log, online redo log, archive log, data database data files and control files, all this. Okay, so you all familiar with the terminologies, right? All we have discussed yesterday. Now we'll talk about the uh, each and every component of this database architecture. Okay, so starting from initiating a request to the data retrieval and giving back that information from buffer pool to the server process and server process to the user process. So let's see how that each and every component works in the Oracle database architecture. Yeah, I'm presenting the whiteboard here. So I'll explain the flow uh, to you guys. So uh, when uh, when you connect to a database server, so what exactly happens? Okay, so after you connecting to the database, so what will happen? So how your query will be executed, how your query will be passed, how your query will be stored. So all these informations we will start discussing about this class today. Okay, so client, so client initiates the user process whenever you connect. Either it could be a, uh, uh tool, SQL Plus tool, or any application or any SQL developer. So that is nothing but a client, Oracle client. Okay, so that client requests for basically whenever you do DML, DDL. Okay, so data dictionary language or dictionary language or data DML queries. So basically, it will be executed in your client machine. Okay, so whenever you you initiate this, a user process will be created. Okay, so let's talk about the user process. What is user process? Okay, so what is the user process? We will understand what is the user process now. So it is a user process is a program. It takes the request from the user and it will communicate with the server process. So user process job is to communicate with the server process. Okay, so this user process doesn't directly interact with the Oracle server. There's no interaction by the user process with the Oracle server. So if anytime the user process wants to connect to the uh, server, there is a request, it has to go through the server process only. Okay, so if any user wants to get information from the DB, they must have to connect to the server process. Okay, so user process must connect to the server process. Okay, the user process starts when there is a request to connect to a Oracle database from the client. Okay, so when there is a request, when there is a command executed in the client, so the user process starts trying to connect to the listener, sorry, trying to connect to the server process. Okay, so before it connects to the server process, there's a concept listener. Okay, so what listener do is listener will validate this request. Okay, whether this request is right, is having the right to connect to the Oracle server or not. Okay, so this listener will have a information of IP, port number, basic network information it will have. Okay, so it will validate the network information whether this client is legitimate to connect to the Oracle server process or not. So this, once the SQL Plus is having all the information, the client is already having all the information, then that the connection will be established, that will be given to the Oracle server process to do the remaining job. Okay. So remaining job in the sense, like, when you execute a DQL query, select query, so remaining job is to get your data with the select query. What is the select query you have done? Okay, it will get the data. Okay, so that will taken care by the server process. So whenever you execute a query, a user process will be started. A user process will be checked by the, like, the user process, whatever the request it has will be checked by the listener. So the listener will have a network information, basic network information, and the SID information, your system instance ID, and the database information. Okay, and then it will validate and give it to the Oracle server process. Okay, so that is the user process. All clear? Yeah, here you can see. So user process started at the time a database user request connection to the Oracle server. Okay, so when a database user connects, so the database user wants to connect to the database server, the user process will be initiated immediately. Okay, so then it will go to the listener. Okay, listener will check this connection should go to the server process or not. Okay, so if it is having a valid database information like server port number, okay, and database name, SID, etc., so then it will establish a connection. Then the connection will go to the server process. So here listener process will start, decides whether this connection should go to server process or not. Okay, if it is everything is legitimate, then it will go to the it will give you a green signal. It's like a traffic controller basically. So the listener will act like a traffic controller for all the requests. Okay, then it will allow based on the information the listener have. Okay, this listener process runs on the Oracle database server. Okay, user process first interacts with the
Mm,
and then connects to the server process. Yes, Carl, you have a question?
I have a question. Means like just wanted to know means between the user process and the server process, listener is basically to build the connection.
Hmm.
So as you said, means like so who did the validation? Means like user have a proper authentication. It means like whatever the password is mentioning or something. It's so listener only manage this thing, or we have a different process in between who will authenticate the things and then it will process. It will go to the server process.
Okay. So
Just one
yeah,
thing I just
listener
want.
only handles the network information. It won't validate, like, you have the user, you have the right access or not. Okay. Okay. So listener,
Mm,
okay, it's a server side process that listens for the connection request from the client application. It handles request over the network, usually TCP IP, right? So basic network information it will validate. Okay, and routes to the correct Oracle database. Okay, it routes to the corrected Oracle database. So there is a file called listener.ora,
mm,
the Oracle server. Okay, so there's a file called listener.ora. The information will be stored in the listener.ora. Okay, so each database, like, if your server is having multiple instances, multiple databases, you can have a multiple database created on the Oracle server. Okay, with the instance one to one, right? I told you one to one instance. So one database, one instance. You can
yes.
get another database with another instance. Okay, you have a multiple instances, but when your user requested for a connection, so you have to be decided, like, which database it has to be connected. Okay, which database it has to be connected, that will be decided by the listener and pmon. Okay, so there is a background process called pmon. So listener and pmon will decides, okay, will decides the database, which database it should connect to. Okay, so pmon again interacts with the listener with the database informations. Okay, pmon process, background process that is actually, so that will also interact with the listener, uh, you know to confirm that the database it is connecting with. Okay, so is a pmon, yes, here. Okay, it's a pmon here. So you can see the pmon background process, right? So that one will let listener that the database services it is running, and it should connect with. Okay, I will talk about like who will validate all these things. Okay, right now let's focus on the listener and the user process. Okay, so once the connection is established by the listener job is mostly done. Okay, it won't come into the picture again. Okay, so it'll be just go away. So but it just continues to listen for new connection again. If there is another request coming from another user, again it'll start coming into the picture. Okay, this listener will only come into the picture when there is a new request. Okay, when there is a new request. So the flow will be like your client, listener, server process, and then database instance. So listener is like a traffic controller. It's like a gateway that accepts and routes the incoming request to the appropriate database. Okay, so there's a file called listener.ora key file. This is a key file for your listener configuration. Okay, so it is a key file for your listener configuration. I will show you, how this listener file looks like. Okay, so in a while. So it contains all the configuration information like protocols, ports, service names, and there will be a TNS name node or also that will be on the client side and both server side as well. So it used to define the connection aliases. Okay, connection aliases that point to the listener network address. Okay, so you need to have something right in the client side as well to connect to the right database server. So that will be there in the tnsname.ora or sqlnet.ora. Okay, uh, we'll see those things in the Oracle server. I have built one Oracle server to show you some things in the practical way to you all. Okay, so let's see. Okay, so till now clear, right, everything? Okay, so once user process is initiated, it connects to the listener and the listener validates the network information and then establish the connection, and then it goes to server process. So it goes to server process. Just a minute, I'm taking my pen. Okay, server process. This. So we discussed about the user process. Now we will discuss about the server process. So there is a link, right, between user process and server process. Listener will be there to establish the connection. So let's put the direction here. Okay, so when a user requested, it goes through user process, then it connects to the server process via listener. Okay, via listener. Okay. Okay, so now let's see server process. So what is the server process? Server process connects to the Oracle database instance, and it started when a user established a session. So when a user established a session, when that session will be established, the listener accepts, and then it'll be established. The session will be established. After the session established, the server process will be started to perform its job. Okay, the server process is responsible for connecting the instance and performing the and completing the request that user requested. Okay, this is very important to complete your user request. Okay, so important process is server process. Okay, so it will connect to your database instance and database to get your request completed. So end to end request, whatever the client is requested, the end to end will be taken care by the server process only. Okay, whether it is a DML or update or select, all will be, you know, taken care by the server process only. Okay, so this one is now very very important. Let's see, like, what are all these stages server process go through to get your information, the requested information. Okay, so server process, once the server process, uh, you know will have a different stages, I told you, right? So what are the different stages? Okay, now parsing will come. Okay, parsing, parsing. Okay, uh, and then binding. Okay, parsing, binding, and uh, execute and fetch. So these are the different stages it has to go through. Okay, so it has to go through. So now you asked, right, one question: who will validate the, whether I have the right user, right privilege to connect to the database server and and any database object that you request to read. Okay, so that will be taken care by the parsing. Okay, so parsing does syntactical and semantical check. What it does? Semantical and syntactical check. And syntax. So syntax check. So syntax check, right? What is the syntax? So if you are giving a query, if it is having any syntax errors, syntax missings, so this syntax will, in the parsing, syntax checks will be check that. Okay, so it is responsible for checking the syntax, and then if the syntax is good, then it will go for a next step. Okay, the parsing will be completed and it will go to the next step. So syntax checks. Okay, when you create a table or insert a table, if there is any misses in the syntax, okay, or any query in that matter, not only creating or selecting a query, any, it could be a DML or DDL, any query that you execute, if it is having a syntax errors, so that will be checked by the parsing. Okay, so syntax checks, it will be done. Okay, and then uh, for example, I'll show you quickly, in the Oracle database server. You're able to see my screen, right? I have created one Oracle database. Okay, I'm the Oracle user. Okay, I'll check what is the Oracle SID. Okay, Oracle DB. My database is Oracle DB. Okay, my instance SQL Plus slash SSDB. So I'm connecting to the Oracle database. What is saying? Okay. Okay. Yeah. I connected to an idle instance. So what does it mean? So there is no instance running on this server. Okay. So let us start up. So what will happen each and every step in the server process I will be showing. Okay. So I'm just starting up the instance and database. So startup command will start both instance and database together. Okay, my database is started now, and it is in a read write. When a database state said opened, it is in a read write. Okay, so now we'll try to create a table. Okay, so we'll show you one table. I'll execute. So okay, I'm creating a table. Create table. Table name employees and employee ID and primary key with the primary key number. Okay, and then first name, last name, email, hire date, salary, and everything. Okay, so I'm just creating this table. So table is created. Okay, so but there's no rows in it. Okay, let's add insert into. Okay, insert into table employees. Okay, mm, we'll add employees. What is the ID number, right? Employee ID one. Okay, we'll have to so we'll give employee ID. Will enter everything. Uh, okay, insert into employees, employee ID, first name, last name, email, hire date, salary. The values are like 101. Employee name is John and last name is Doi. So his email ID and sys data I'm created. Okay, one row is created. Okay, so now let's see. Select star employees. Sorry, select star employees. So what will happen now? It will state a keyword is missing, which means it is checking the syntax. Okay, so I written a wrong syntax here. I did not give a select star from is the keyword I missed here. Select star from employees, right? That is the right syntax, but I have given a wrong syntax here. If I have a some spelling mistakes also, instead of select, SELEST, okay, I'm just select star from employees. Now I'm given everything, but spelling mistake, there is a spelling mistake. Okay, so only so this is the right syntax. Okay, then it will give you the information of the employees table. Okay, so the parsing will check whether your syntax is right or not. It has missing any keywords. It is with the any uh, uh, any issues with the spelling issues or anything. It will check, and then it reverts to the error. Okay, if it is correct, it will go back, the go to the next stages, and then get your data. Okay, what are the next stages I will discuss, but just understand the parsing part. So parsing will have a semantical and syntactical checks. Okay, so now you understand the syntax checks. So let's do understand the semantic checks also. What is the semantic check? So one asked about this, uh, you know, uh, related to the who will identify or check the information of whether that user is existing or the object is existing or not. Okay, so this semantic check will do that. Okay, you're accessing a database. Okay, you wanted to access a table where you don't have a privilege. Okay, you don't have a privilege to access that particular table. So that will be checked by the semantic, whether you have access to that particular table or not, whether you are whether that object is available or not, the table is available or not, will be checked by the semantic checks. Okay, let's see that example also. I will uh, you know do select star from department. This table does not exist. What error it shows? Okay, it says table or view does not exist. It says table or view does not exist. So this is semantic checks. Your privilege objects information will be checked here, and it'll, if it is there, it'll go to the next step. If it is not there, it immediately throws you error. Okay, it sends back that error information to the user, and user will see this information table or view does not exist. You getting my point? So it will check, the semantic check will do the uh, privilege check, object existence check, and dependency checks also. So if your query is having any dependencies like index, triggers, functions, anything, that will also be checked by the uh, your semantic checks. Okay, okay, so now your checks are done, your query is good. What will happen next? Okay, so if your query is not good, you will get a feedback. Okay, you're missing any objects, like if you're trying to access any object without a privilege, or if the object is not there, you will get a feedback at the semantic check. So now your syntax checks are done, semantic checks are done, you have an access to the table. So what will happen next? Okay, so what will happen next? It goes to the shared pool in the Oracle database memory components, SGA. Okay, so now before we go to the shared pool, what are the other things happens in the server process? Let's learn that. Okay, Let's learn what the other processes it will have. Okay, so we parsing will happen in the server process. Binding, so what is binding in the SQL in the server process? So binding actually does bind your network information. Okay, and allows uh, so basically it does bind your network information in the server process. So it is like a, request form. Okay, so when you request, so there will be a request form. So there, uh, you know it will have a placeholder. So there will be a session created, right? So for that session created, what are all the session details it has to be there, that will be there in the binding. Okay, you're all getting what is binding? So during the bind phase, the application passes actual values, okay, to the SQL statement. So the bind, like the statement is already passed or ready to be passed, and uh, that information, what are the SQL query you have, okay, those actual values will be binded over this binding phase. So basically your SQL information. So this will, when this will come into the picture, when you execute this same query next time, okay, when you execute the same query, it avoids the parsing, because your already parsing is done. Your query parsing is already done. The same query you're executing, then it will avoid that parsing, okay, because you have already done the hard parsing once. So then it will avoid that parsing. Okay, so because it will have the information whether it is parsed or not, okay, then it will go to the execute. So what will happen in the execution phase? So execution phase actually runs the SQL statement, okay, after parsing and binding. Okay, after parsing and binding, the execution will happen for the requested SQL that requested by the user process. So there were the server accesses the required data blocks after, you know uh, like it will get all the data blocks from the data files to the buffer cache, and then from there you will get the information to the server process. So that server process will take that information back to the user process. That process is called fetch. Okay, fetching the information from the buffer cache and database file and giving back to the user processes. The stage is called fetch. Okay, fetch is the word, is the process, will do the fetching of the information. Okay,
So just wanted to miss this parsing, binding, execute, and the fetching.
Mhm.
So this is a process, or there's a component inside the server process who do these things. Just to,
Yeah, these are the steps that server process does when a request comes.
okay.
Okay, so these are the different steps it goes through. Different phases it goes through before it gets a data. Okay, the completes your request. Okay, again parsing also will have a different types: hard parsing, soft parsing. Okay, hard parsing means the first time when you are executing a query, when it goes through the server process, okay, that will be a hard parsing. So that will be a hard parsing. The next time when you execute the same query, it goes to a parsing, then it will be a soft parsing, because it will have the information binding information to that. So that query will be stored in the library cache. That I will talk. Okay, that I will talk. Right now we will understand only server process. So what server process does, and each and every step of server process it will go through. Okay. Okay. So we learned, like, server process. When a user logs onto the Oracle database server by specifying a username, password, and a database, a process is created on the database server machine, that is running on the Oracle server. So this server process communicates with the Oracle server on behalf of the user process that runs on the client. Okay. So as I told you, user process won't directly connect to the instance or Oracle server. Only server process only connects on behalf of user process. Okay. So in this server process, different stages will be there. Okay. Parsing. So in this stage, the user process sends the query to the server process with a request to parse or compile the query. Okay. So request to parse or compile the query. So the server process checks the validity of the command and uses the area in the SGA known as the shared pool. So we'll talk about SGA. Okay. Uh, Known as the shared pool to compile the statement. At the end of this phase, the server process returns the status, that is either a success or failure. Okay, it will do the checks, and whether those checks are success or failure, it will send that information to the uh, user process during the parse phase. Okay, so then execute binding. I have already told you, right? It will binds the actual data. Okay, actual SQL queries. Then execute. What will happen during this phase? uh, in the processing of query, the server processes prepares the retrieve of the data. Okay, it will prepare for the retrieve of the data. So from where it will be retrieving the data. So where the data will be actually stored, I will discussing. Okay, I'll be discussing after the uh, server process. Okay, and then fetch. Okay, the rows that are retrieved by the query are written by the server to the user during this phase. So it will be depend on the amount of memory that you have allocated. Okay, the fetch process will be happening. So you understand, right, all the four different stages that happens in the server process. So now I will talk about. So we discussed user process, server process. So what next? What will do the server process? It will connect to the instance. It will connect to the instance and database on behalf of user process. Let's talk about that now. Let's talk about the next stage. Okay, so now your server process will connect to the instance. So SGA instance again will have a memory components, SGA and PGA. So okay, so now what will happen? Your server process will have a PGA. Okay, it's a private global area, program global area. It will have a private memory. Okay, so each and every server process will have one PGA. So if you have 100 users connected to your database server, 100 users will have a 100 Oracle processes running, and 100 PGAs will be there if it is a dedicated server mode. Okay, if it is a dedicated. Okay, there are two types: dedicated and shared server process. So if it is a dedicated, so it will have a one single server process for one single user process. Okay, if it is shared, it will have a shared server process. So it I will talk about, like, difference in shared server process and dedicated server process. So shared Oracle will purely depends on, like, whether it is a dedicated server configuration you have, or shared server process configuration while you are creating a database. It depends on that. Okay. So what will happen, when you have a shared server process. Now I'm talking about that. So what will happen if it is sorry, if it is a dedicated server process I'm talking. So it will have a one SGA, one dedicated SGA, dedicated private area to it, and a dedicated server process runs for each and every user process it has. So within the case of um, shared, what will happen? Okay, what will happen? Shared server we have configured. So when to configure a shared, when to configure a dedicated, I will also talk about that. So 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 dedicated means where each user gets a separate server process. Where shared server means where multiple users shares a pool of server process. There will be a pool. Okay, from there a server process will be allocated to a user process via dispatcher. Okay, dispatcher will come into the picture. So dispatcher will be there. Okay, let me this sorry, this is whiteboard only. Okay, okay, so here dispatcher will be there. Okay, so that dispatcher will complete the uh, user request. So 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 Oracle server process will be shared for all the user process. If you have a 10 user processes are running concurrently, so 10 dispatchers will be assigned to them by the Oracle server process. So here dispatcher is a lightweight process again. So it will be divided into a lightweight processes. If while you are configuring your server in a dedicated server process mode, so you can mention like how many uh, you know uh, connection it can accept one server process. Okay, if you mention 100, it can accept one server process can accept 100 user processes. Okay, if you mention 10, one server process can accept 10 user processes via dispatcher. So each and every time a user connects, it go through a dispatcher and get the user request completed. Okay, so so when to use dedicated server. So you know only few connections, those are connecting to your server. Okay, and that time you want user to get a dedicated process, and you know user should complete the uh, queries quickly, and you want more throughput and high performance. Like you want user queries gets immediate responses. At that time you can go for a dedicated server process. Okay, when you need a high performance, uh, you can distinguish like when you have an application, OLTP applications, OLTP systems, where each user requires continuous and stateful interactions. At that time also you can choose dedicated server process. Okay, and where you are running a resource intensive operations. Okay, some long running queries, complex transactions, or any analytic tasks. So then at that time you can better go for the dedicated server process. Okay, because it will be dedicating some dedicated memory and CPU for the resources. Okay, so each server process will have a dedicated memory PGA and CPU. Okay, it runs on the CPU, right? So it will have a some CPU allocated to it, some resource, right? Both memory and CPU will be allocated to the process, so that it can quickly get your request completed when you're running a long running queries or complex and transactions or OLTP transactions. You can use your system in the configured way to accept dedicated server process. Okay, so when to use a shared server process? So when you have a many concurrent users with the light workloads, okay, light workloads, I would say, like, just, select queries, small select queries, okay, a web-based or middleware users connects briefly and performs a simple queries. That time you can use the shared server process. Okay, so when you know, like, you have a limited CPU, limited hardware, you can decide, like, I wanted to utilize my server optimally. Okay, I wanted to be careful of my resources and wanted to allocate thoughtfully to the servers and, user process and everything, like, you wanted to control that, then at that time also you can do this. Okay, so it can support this shared server process also supports thousands of users concurrently. Okay, and that is also, like, without overwhelming the server resources. Okay, so if you know that, those are all very lightweight queries. Okay, so you can rather going with the dedicated server process, because again every user process will have a dedicated process, means, like, it will have a separate PGA. Okay, separate memory and separate CPU, that will overwhelm the database server if you have a lesser resources. Okay, if you have a lesser resources, go with this. If you know that, there will be running well only simple queries, then go with this shared server process. Okay, so this Oracle server process will be two types. One is shared and another one is dedicated. Okay, shared will have a multiple dispatchers, and that dispatcher will take care of the request. Okay, so there will be a request queue. So based on the priority of the query, it will be decided, like, when that particular query has to be executed, and, fetch the information and give back to the process. Okay, let's go to the memory components. Any doubts till now?
Earlier, as you have, means you have shown means like every session or every user process have their own server process and then their own PGA.
Yes.
So if it is dedicated only, then only it will be the own process and own PGA. If they are shared, then the every session will be shared with that particular server process. Yes, so, yeah.
Yes, you are correct. So okay, dedicated will have a one server process and one PGA. Okay, shared will have, okay, dispatcher. Okay, shared will have a lightweight, it is a lightweight processes actually. Okay, shared mode, if it is a server process in a shared mode, the server process will be divided into multiple dispatchers. If you have a 10 connections concurrently, 10 dispatches will be allocated to it. Okay, if you have 100, so based on your configuration you can configure, like, how many dispatches one server process can create. Okay, so for example, you are creating a database with the shared, okay, shared server process. Okay, okay, so then you configured 10, 10 it can divide up to 10, up to 10. Okay, so once this 10 users are connected. Okay, so once this is completed, okay, one one server process will take care of, okay, one server process can take care of this 10 connections, and now you got another 10. Okay, so what will happen, another server process will be initiated. Okay, second server process. Okay, will be initiated to handle that additional 10 user connections. You're getting? So now what we are doing is like, earlier we are giving a dedicated server process for every user connection. But now we are giving a one server process for multiple user processes. You're optimizing it actually. You're optimizing the processes running on your database server. You're
So
getting it?
nowadays we are using shared or dedicated, dedicated, right?
Now
Or
we are not using, I'm telling you the concept. I'm telling you the concept. Which
yeah,
one?
yeah, means
Yeah. Which one?
nowadays means every.
It depends. It depends on the business case. Okay. So which one to use, you have to decide. Okay. You're That's what I'm told you right now, when to use a dedicated, when to use a shared. You have to decide, like, that you're having very lightweight queries coming from the users. There's no resource intensive queries coming. There's no long running, there's no oltp transactions are happening. Then you can go for the shared. You can optimize the lot of memory, you can optimize the processes running on your server, right? Your server will be very good when you go with the shared shared server process. Okay. When you have a intensive resource incentives, long running queries, a lot of oltp transactions, you need some agility, performance, and then at that time you can go with this dedicated. It's in your hand which one you want to go with.
This is instance level setting, right? But once we need to set, and then every
Server
process,
level.
every section will use the same. Yes,
Yes.
several. So
Yeah. Yeah. Okay.
okay.
Yeah, you're clear. Okay. So once, you know I explained all this, types, right? Server process will be two types: dedicated, shared. And within that server process, what are all the steps will happen: parsing, binding, execute, fetch. Okay, let's see. So what will happen next? Okay, from the architecture. Okay, that's the architecture. Okay, so it connects to your database instance and database server. Oracle process connects to your database server. Okay, so what your database server is having: SGA, memory components, SGA, PGA. Okay, so I will talk about PGA as well. Let's focus more on the SGA. Okay, so what is SGA? Okay, system global area or shared global area. Okay, so let's go back to the presentation again. Okay, so let's try and understand the memory architecture. So the next process of the uh, you know server process is to interact with the memory only, memory, and interact with the database also. So it interacts with memory and database, it interacts with. Okay, so let's see what will happen now. So basically a memory, in the memory architecture, so you see, right, two components. uh, that's the that's one of them is system global area, the other one is program global area. Okay, so you can see system global area, okay, and program global area, PGA. Okay, so you can see here right now two users are connected. Two users will have a two PGS. Okay, since it is running with the dedicated server process mode. Okay, all right, so now look at this SGA in a magnifier. Okay, so in a magnifier, what XGA will have. Okay, so SGA will further divide it into multiple components. Okay, so first one is shared pool. Okay, first one is shared pool. The second one is what is the second one we have? Buffer cache. Where is buffer cache? Where is it? Shared pool, it is showing directionary server results cache. Okay, we'll go to the architecture. Okay, Let's only look at this system global area and PGA. So memory architecture is subdivided to system global area and PGA. Okay, let's do some magnification on the system global area, and let's talk about each and every subcomponents a system global area is having. Okay, let's go. Okay, so what is a SGA? SGA is a group of shared memory structures: database buffer cache, redo log buffer cache. Okay, and each instance has its own SGA. So when your database server have one instance, means it will have one SGA. If you have a two instances, two SGAs. You can have a multiple instances installed in your server. Okay, based on your RAM resources available, you can create n number of instances. In a real world, basically we will be creating one instance, one database. Sometimes two instances also. If you have a different versions, you can also create a two instances, two databases. Three instances, three databases also you can create based on your resources. Okay, so Oracle automatically allocates memory for an SGA when an instance started. Okay, so it is a shared by all server processes and background processes. So this SGA will be shared with all server process and background processes. Okay, if you have 100 server process, this SGA only be shared. Okay, so we will also call the system global area as a shared global area also. Okay, this will be shared for all server process and your background processes. Okay, so all your server process and background process will be shared. This SGA will be shared for them. Okay, so it is shared among multiple users who are concurrently connected to the same instance. Hence, it is sometimes called as a shared global area also. Okay, shared global area. Mentioned right. System global area also called as a shared global area. So the OS deallocates the memory when the instance shut down. Okay, when the instance is shut down. Okay, and part of the SGA is called a fixed SGA. So, so the purpose of the SGA is to hold the data and control information of one database, one Oracle database instance. Okay, so let's see. We have started our database, right? So we have started our database. So when you start your database, what will happen? Let's see that. That's my query. So you have started your database, right? So I explain this now. Okay. So what will happen in each and every stage? Okay. Starting your database. So first thing, what will happen when you start up a database? It will read a control file. When you execute this startup, so the first step it does is the reading your parameter file. Okay, will write steps when you execute your database startup. Okay, first it reads the p file, we call it as p file or parameter file. Okay, and then the second step, it allocates the memory structure. Okay, it allocates the memory structure. You see, right? So SGA, the system global area, you immediately saw this, right? So when you start Oracle database, okay, so Oracle instance started. So while Oracle instance is started, it will have a its own SGA, okay, it'll have its own XGA, and then fixed size. What is fixed size? I will talk about fixed size and variable size and database buffers and your redo buffers, okay. So these are all your memory components, okay, these are all your memory components only. So allocates the memory structure when you start up your database. As a second step, it will allocate the memory structures. What will happen in the third step? It starts the background processes, okay, it starts the background process. And fourth step, what will happen? So after the memory allocations, it start all your background processes. Then fourth step is the database is mounted. So database mounted means it is opening the control file, okay, control file. Basically the database is in mounted state, okay. So the database is mounted. Here the database is no mount state, okay. No mount state, only instance is started but not your database, okay, only instance started. In that scenario we call that state is no mount, okay. When a instance only started, then you can state no mount. You can only start the instance also from the database server, okay. You can only start the instance. That time what will happen? It reads the parameter file, it allocates the memory structure, your SGA, database buffer, redo buffer, everything will be allocated. And then uh, it goes to the no mount state, okay. From the no mount state, you want to open a database, the database needs to be mounted. When you say database mounted, it will be reading your control file, it will be opening your control file, right, one of the database file, okay. So control file, redo log file, and data file we have right now. Database is nothing but CRD, control file, redo log file, and data file. So one among those files is control file. So when you say database is in mounted state, it reads the control file. Then then the fifth state is opening the database. So opening the database and read logs. Opening the database and read logs. Okay. The other file you see it, right? Read logs. So in this state, database is in read write. Okay. So in this stage only you can connect to your database and do the retrieval. Everything you can do it. Okay. When you have an instance started up, you cannot do anything. Once the instance is mounted, you cannot see any objects within the database, okay, which means your CRD files. For that you have to open the database. How to open? First you need to mount the database, which means you need to read the control file, open the control file. Then it will be opening the database and redo logs, okay. So without a instance you cannot read the database. Without instance startup, you cannot access the database also, okay. Only instance started also, you cannot open the database until it is opening, okay, until it open the control file, until it open the database and read the logs, okay. So now see, like, what exactly is happening in this startup. So main thing, the first step, it is reading the parameter file. So what is parameter file? uh, uh, let's see where it is, the parameter file. So this is your parameter file, okay. This is your this file, okay, this file will be, sorry, this file will be used while your database started. Whenever you start up a database, first thing it'll do is reads the parameter. All your configuration uh, parameters will be available in this parameter file. All your configuration information will be there in this parameter file. With this configuration information only, the memory structures will be defined. Okay, you can define your SGA, you can define your buffer cache, you can define your library shared pool. All this, information you can define in this parameter file only. Okay, so this is very crucial file to start up your instance. Without a parameter file, you cannot start up your instance, because this is the first place it checks how I can allocate the memory structure. Okay, you understood? So parameter file is very important file, very very important file. Without this, the instance won't start. Okay, so this is the reference point to start your instance. How, what kind of sizes it can allocate to your memory. Okay, so let's go back to the SGA now. So the first component what a database reads is parameter file, then immediately it goes to the SGA. Okay, uh, it mentioned, right, in the server also. Where is it? Okay, I've written in the notepad. Okay, server, what it written, the total system global area so and so bytes have been allocated, and then fixed size. These are all nothing but your SGA only. Okay, fixed size, variable size, database buffer, redo buffer, all are your SGA only. This entire part is SGA only. Okay, let's discuss this SGA now. Okay, I'll take out. Okay, so this is your SGA. So SGA have multiple components. So the purpose of the SGA is to hold the data and control information of your Oracle database instance. Okay, so let's divide these parts. Okay, so I'll divide based on the importance of this each component. Okay, the first component I would say is shared pool. Next is database buffer cache. And the third one is redo log buffer cache, and fourth one is large pool, Java pool, stream pool. Okay, so let's get a deep dive into first component. Okay, shared pool. So let's look at the shared pool. So this is very important. Our server process interacts with the shared pool only. Okay, so immediately after it does the parsing, okay, shade pool will be coming invoked. Okay, coming into the picture. Okay, so what is shade pool? uh, okay, what is shade pool? The shade pool is like a buffer for SQL statements. Okay, buffer for SQL statements. So Oracle parsing algorithm ensures that identical SQL statements do not have to be parsed each time they are executed. Okay, it consists of two key performance related memory structures. One is data dictionary cache, the other one is library cache. Okay, the shared pool will have a two subcomponents, two performance related memory structures called data dictionary cache and library cache. Okay, the shared pool is like a buffer for SQL statements. Okay, and the total size of shared pool can be determined by the parameter in the parameter file I told you, right? Shared underscore pool underscore size. This is the parameter. You can define the size. Okay, so the default value of parameter is 8 MB on 32-bit platforms. So nowadays we are not using the 32-bit, all are 64-bit only. So the 64-bit platform, it is 64 MB, the default value of your shared pool size. Okay, the default value of your shared pool size in the parameter file without, before your configuration, like when you do a fresh installation, you are not configuring anything, you are just creating an instance. The p file will have a default configuration, so that is 64 MB of size. from your RAM will be allocated to your shared pool size. Okay. So increasing the value of this parameter increase the amount of memory reserved for the shared pool. Okay. So what is the purpose of shared pool? So it stores the most recently executed SQL statements. The first statement it was mentioned, right, in shared pool is like a buffer for SQL statements. It stores all the SQL statements, recently executed SQL statements. Okay. So this will increase the performance. When a user executes a query for the first time, it will go to the parsing, and that query will be stored in the shared pool. Okay. That query will be stored in the shared pool. So so shared pool acts like a SQL buffer, and all your SQL statements will be available in the shared pool. Okay. And not only SQL statement, your execution plans also. Okay. Your execution plans, your SQL hash value or execution plan will be also stored in the shared pool only. Okay. So whenever the user executes the query next time, the same query, okay, that query will be available in the shared pool. So the query in the sense like, no, the query is execution plan. So execution plan, what is execution plan? So execution plan decides how your SQL query to be executed with the less resources. Okay. What is the best path to go ahead and read the data from your data file? Okay. Who will decide this execution plan? There is a engine called optimizer in a database server. So that optimizer will decide the execution plan, how much resources it can utilize to you know complete the execution of your SQL statement. Okay. All most recently used data definitions also will be stored in the shared pool. So shared pool is subdivided into two, right? So what is the two components? One is data dictionary, so the other one is uh, library cache. So let's learn about the data dictionary. So data dictionary is one component within the shared pool. It actually have a metadata of your objects. Okay, metadata of your objects. Earlier, while we are doing the parsing, semantical and syntactical checks are happening, right? So that time, so it validates the privileges, it validates the objects also, right? And then the semantical checks, where that objects resides, and now that information will be fetched is from the data dictionary only. Okay, so it checks from the data dictionary whether that object is available or not in the semantical check. You're getting now, getting connected to it, right? During the semantical check, so it will check the data dictionary. So data dictionary will have all the tables, objects, index, all like all the database objects information it has. It can be table or index, anything. Okay. So only Oracle can write or change data dictionary information. Oracle provides scripts to modify the data dictionary tables when database is upgraded or downgraded. So you cannot do any modification to a data dictionary. Okay. So it's a inbuilt. Okay, inbuilt it will have all your data dictionary views will be there. So inbuilt. So you will not be able to modify them. So it can only be modified by the Oracle when you are doing the software upgrade or downgrade. So new, if there is any new data dictionary needs to be written, it will do. Any changes to the data dictionary, it should it should do. Only Oracle can do that. Oracle software only can do. Okay. So Oracle modifies the data dictionary after execution of every DDL statements. So data dictionary cache, you understand about the data dictionary. What is the data dictionary, right? What is data dictionary cache? Tables and views are stored here. Data dictionary cache. There will be a cache also. All the tables and views will be stored here. It has the metadata information about the tables and indexes of the database. So much of the data dictionary information is kept in the SGA, in the dictionary cache, because Oracle constantly access the data dictionary during the database operations to validate user access and to verify the state of the schema objects. So this part, right? The semantical check, right? Happens. So the data dictionary cache is like a buffer cache, but it contains Oracle data dictionary information instead of user information. Only Oracle data dictionary information it will have. It will not have any user information. Though it is a cache, it will only have the cache information of Oracle data dictionary. Okay. So the purpose, it used to cache data dictionary related information and RAM for quick access. Okay. So when you execute query, when you are doing a semantic check, you don't have to read the data files. It can directly read from the memory itself, whether the object exists or not, whether you have a privilege or not. When you wanted to read from the data file, it will be really taking a long time. RAM is quicker than disk write. That's the reason they have this component in the memory itself. Okay, within the SGA shared pool will have the data dictionary cache. The next one is library cache. Okay, this is one another important one, library cache. So the Oracle shared pool contains Oracle library cache, which is responsible for the collecting, parsing, interpreting, and executing all the SQL statements that go into the Oracle database. So the server process will connect to the shared pool, and the library process will do the collection of those queries, parsing of those statements, and compiling and executing of those SQL statements that should go into the Oracle database. So again, library cache have two subcomponents: shared global area and PLSQL package processes. So what is shared global area? That stores each SQL statement that executed in the database, shared global area. So, so there is a place right in the shared pool. What is the place? Shared SQL area. Okay, where all the SQL statements, all your SQL text will be stored. Okay, this area allows SQL execution plan to reused by many users. Once the SQL text is stored here, whenever there's a user starts or executes a same query again, the same execution will be taken from the SQL shared area only, shared SQL area. That execution plan will be here. Okay, so PL SQL package and procedures. So this is another area within the library cache. So this PLSQL area used to hold parsed and compiled program units, PLSQL program units, which allow the execution plan to be shared by the many users. Okay, so all the packages information will be permanently stored here. Okay, the purpose here of the library cache is to avoid reparsing the same query repeatedly and reuse the execution plans to improve the performance, and reduces the CPU usage by skipping the return and parsing. So you don't have to duplicately parse the same query again and again. It will store that in the memory that so and so a person so and so query came uh, to me, and it was done a parsing. Hard parsing is done one time, so then next time onwards it has to go through the soft parsing. You don't have to do any you know execution plan created for this again and again. So this is the shared pool. This is very important component in the memory. You need to really understand all of them, because it plays a very crucial role with your server process to store your SQL text and creating a execution plan and do the execution. Everything will happen here only. Okay, so this is one of the component which will be deciding your performance of your Oracle database server. Yet, so this is, where is it? Where is the share pool? This is the component. Okay, shared pool. Oracle server process connects to the share pool. Library cache will store the library of SQL text, and it's kind of a library. It will store all the SQL queries coming into the Oracle database. Okay, and their execution plans. So, what is the execution plan? It has to be taken and run those execute those queries. Okay, so those execution plan will be decided by the optimizer. okay, database engine called optimizer. And then the data dictionary cache, it will have all the dictionary information of your Oracle database. So it's kind of a metadata. So where your objects located, and where your basically all your tables and indexes are located. That information it will have, and privileges, what privileges those tables and objects are having. And result cache. So all the information results will be stored in the result cache. Okay. So this is a first component, shared pool. Okay. So you're all clear till this point? Shared pool. Guys, are you there?
Yes, yes, yes.
Okay. So explaining the architecture in depth in a one day, it'll be a bit difficult. Okay. So we might take 2 to 3 days to completely understand this architecture, each and every components, because we're going each and every component deeply, understanding them. Okay. And then a relation also in each and every component, how it is related to the one each other, we're understanding. So just be patient in learning this. The more you pay focus on this, you will be more proficient in managing other database administrative activities. Yeah. So we will close this SCA today. Okay. So other components also. What is the database buffer cache? So your user process, your Oracle, like you understand, right? User process will connect to the Oracle process. Then Oracle process will connect to the shared uh, pool. Okay. And then shared pool, that request, like it will validate parsing and storing that SQL text, and validates do the semantical and syntactical checks. And then uh, it creates the execution plan and then executes. Okay. So what will happen once this executes? Okay. What will happen once the query executes? The Oracle process, if a user executes the query, select query for the first time, the Oracle process go to the data file. Okay. Go to the data file and get the data in the form of data blocks. Okay. To the database buffer cache. So in the database buffer cache, data blocks used in the memory. So it is in the form of data blocks. Okay. Buffer cache will be in the form of data cache. Okay. So the data will be taken from the data files in the form of data blocks and kept it in the buffer cache. Okay. This is a temporary space, okay, to access the data quickly. Okay. Whenever you access a data for the first time, it goes to the data file and fetch the data and put the data in the buffer cache. Okay. Whenever you execute the same query second time, it need not to go to the data file. It can directly read from the uh, your database buffer cache itself. So database buffer cache memory will be in the form of data blocks. Okay. So data blocks, each block contains 8K in size. Okay. Each block contains 8K in size. Okay. Okay. Now you understand, right? After parsing execution, so what the server process does is, like it connects to the data file and gets the data in the form of data blocks to the data buffer cache. So and keep it here. Okay. From here, the data, so for example, you have written a select star from so and so table. The table data will be taken from here. Okay. You see this dotted line, right? It taken from data buffer cache to the Oracle process, from the Oracle server process, from the Oracle server process to your user through the user process. And output will be available for the client, okay, on their machine. Okay, so all the database all the temporary data will be available in the buffer cache. Okay, so let's see, what is this buffer cache? What is this buffer database buffer cache? So database buffer cache is a cache where Oracle stores the data blocks. Okay, any data coming in or going out of the database will pass through the database buffer cache only. Okay, the database buffer cache are organized in two lists. One is write list, the second one is the recently used list, LRU. SQL also you might hear about this, right? LRU, recently used list.
Least recent use. Yes.
Yeah, so you will be able to connect to it. So the write list holds the dirty buffers, okay, and the LRU list holds the free buffers and pin buffers and dirty buffers that have not yet been moved to the write list. Okay, so then the parameter file, what is the configuration parameter you have is in the parameter file is the db underscore cache underscore size is the parameter to set the database buffer cache size. Okay, so the purpose of the database buffer cache is to, when an Oracle receives a request to retrieve the data, it will first check the internal memory structure to see whether the data is already in the buffer or not. So this will allow the server to avoid unnecessary IO. It need not to connect to the, it need not to go to the data file every time. Okay. So whenever Oracle server process receives a request, it will check first the buffer. Okay. It will check the buffer memory. Okay, internal memory it is. So if it is not there, then it will go to the uh, data file and reads and gets the data blocks to the buffer. Okay, and therefore this buffer cache will enable great performance when you obtain and update a data. Okay, so each and every time you don't have to go to the data file to read the data. Okay, once you do the first time, it will keep the data temporarily in the database buffer cache. Okay, so next time you execute, it will do the uh, uh, read from the buffer only. Okay, so when you read from the data files, when you execute a query from the user for the first time, when you read it from the data file, that process is called physical read or a disk read. Physical read or a disk read. Okay, that process is called physical read or disk read. Okay, we need to reduce that disk reads so that it will reduce the unnecessary IO. For that reason, this buffer cache will be responsible for holding data blocks temporarily in the database buffer cache to have a quicker access to the data whenever there is a request come from a user. Okay, so this is the buffer cache. So it has a uh, two lists, write list and LRU list. So LRU list will have a free buffers, pinned buffers and dirty buffers, all this information before they move to a write list. So write list, whatever the information there in the write list, so whenever there is a update or changes happen to your data, so basically first it will be there in the buffer, LRU list. From there it will move to the write list. When there is a data in the uh, uh, write list, that information will move to the data file with the help of data writer. I'll talk about the data writer. Okay, so this is your data writer. Okay, this is your data writer will move the data from database buffer to data file. Okay, so when the data written in the uh, writer list. Okay, so when this database writer will come into the picture, we'll talk about that. Okay, so what are the different cases this database writer will come into the picture and takes the data from the database buffer cache to the data file. to store it permanently. Okay, so we talked about the database buffer cache, and we talked about the shared pool, and we have a few more components. Log buffer. So what is a log buffer? So log buffer, um, all the changes from database buffer cache will be written to the log buffer. For example, you have an update query, so there will be some changes in this database buffer cache. So those changes will immediately move to the log buffer. Also that server process will do the changes written in log buffer and written in server like in your database buffer cache also. Okay, so log buffer will basically tracks all the changes that happens to your database. Okay, and then from the log buffer, those changes will be written to your online redo log files. Okay, all the changes will be written to the online redo log files. Those are change vectors. Change vectors will be written to your online redo log files. So to write your changes to online redo log files, there's a background process coming into the picture, which is nothing but a log writer. Log writer, from log buffer to online redo logs, it will be writing the information, all the changes it will be writing into the redo logs. Okay, online redo log files. So online redo log files are one of the database file. Okay, from the CRD files, control redo log database files. Redo log files one of the database file. It tracks all the changes that happen to your database. Okay, so when this will come into the picture, log writer will come into the picture and writes the log buffer. We'll discuss tomorrow. Okay, so just to know understand what next from after the database buffer cache. Okay, so we have another components like large pool, Java pool, streams pool. So large pool is one component where it will be used for the large IO operations. For example, backup and recovery, if you're doing with the rman, it requires a more IO. At that time, this large pool will additionally give memory to the process to run those operations. This is like extra memory, I would say. Okay, so whenever you do shorting operations, you need an extra memory. That time large pool memory will be allocated. Okay, so Java pool is something like when you have a Java related applications, which means like Java code runs, JVMs. At that time, Java pool will come into the picture. If you don't have an application with the Java pool, Java related, then Java pool is not required. It's not coming to the picture. And stream pool also, it's an optional. So this is one component in the memory. So it will be coming into the picture if you have a replication setup in the Oracle database. So then it will come into the picture. Replication is there, then the stream pool will come. It does replication between primary, secondary. Okay, so those replication processes it will take care. That time stream pool will come. So there are some background processes runs, and that time those background processes use the stream pool. Okay, all right. That's it for today. We'll talk further tomorrow, like in the some more in the practical side as well, how each and everything happens. Okay, and the background processes. So what each background process does, and when it does, when it comes into the picture, and all this we'll be discussing tomorrow. Till now, any questions?
No, means like uh, no right now because I think some of things still I think need to be covered, right?
Yeah,
Like
yeah,
regarding the processes.
yeah.
DB writer checkpoint. Okay,
Tomorrow we will
means till
complete.
now what you have said means yeah, it is
It is
yeah.
clear, right? Till now, whatever I said with the practical and how database instance started, all these things. Okay. So
Yeah,
yeah,
for yeah, for first time this thing, and then it means like yeah, we understand. Maybe we need to go through it again and again. Then we will
yeah.
know
Again,
it
I mean,
better.
like
We will understand better.
everything in a brief again and again. So you need to completely understand the architecture, and explaining this architecture in single class is not going to happen. Even if I explain, also it will be overwhelming to you people. Today we have extended a little bit. Still, right now I cannot complete the complete architecture. So tomorrow we will touch base on again this memory components. Again, we will talk about the uh, process background processes. Okay, when these background processes are invoked and do their jobs. So what scenarios they will come into the picture? What scenarios they will complete their jobs? Okay, cool. I'll
Okay, sure.
run again
Thank you.
and we'll complete this. Hopefully, we can get architecture complete tomorrow. Yeah, Rahul, you have any question?
Also, okay. No, I think parameter file, I think, means maybe I need to understand the parameter file things. But yeah, in future, I think they're going to
We will
uh,
Oracle database, right? I will show you what are the
focus on that more on that. Means like yeah,
yeah.
yeah.
Yeah, during the installation, we can go to
We
this
have a
parameter file.
SP file as well, right?
Yeah, that is the SP file, P file, parameter file only.
Yes.
Okay.
Yeah. Okay.
All right. All right. We'll end the recording now. We'll catch up tomorrow.
Thank you.
By the way, tomorrow you guys are comfortable to join the session.
Sure.
Okay. We will close the architecture tomorrow.
Yes, I'm okay.
Yeah. We'll close the architecture tomorrow. Okay. All right. Thank you all. Yeah.